we're going to look at calculating regression lines. Here we have some data that matches up chest sizes of bears with their weights. And we want to see if a regression line is going to be a good predictor of weights if we know the chest size of bears. Before we use a regression line as a predictor, however, we need to make sure that there's a linear relationship between the variables. We don't want to use a line for predicting if the relationship between the variables isn't even linear. So we're going to do a hypothesis test on the correlation coefficient first to see if that data is has a strong linear correlation. So we'll open our data in StatCrunch. And we will find the correlation coefficient between those two variables. And then we're going to compare that to our Pearson's R. Again, our significance level is 0.05 and we have 6 data points. So we're going to look in this column and 6 data points. So there's our critical value. And again, there's our correlation coefficient, and we can see that our correlation coefficient is greater than the critical value, and so we're going to reject the null. The null is that there is no correlation, linear correlation between those variables. We're rejecting that and saying that there is a linear correlation. So that means that we're rejecting the null, so that means there is a linear relationship between those variables. And so we'll use a prediction line to make, a regression line to make our predictions. Otherwise, we would use the mean of the y's, which we could also calculate using StatCrunch. But if it didn't have a linear relationship between the variables, we would just see sort of what's average, what's expected for the weights, and use that instead. So we're going to do a regression, a simple linear regression. The x variable is the chest size, and the y variable is the weight. And this brings up our results here, and it gives us the y-intercept and the slope. So if we round to 2 decimal places, we get the y-intercept and the slope. The slope is what's multiplied onto your x variable. What that means is for every inch in chest size that we increase, we're going to increase the weight by almost 11 pounds. And then we'll use this to predict. So let's bring up our calculator. And we can start with the negative 227.27 pounds, and then add on I need to do this in the right order. We're going to multiply by our x variable that we're interested in making a prediction for, which is 57 inches. And then we'll take off that y-intercept here. That's negative. We should get 406 pounds. Alright, I hope that helps you use StatCrunch to make these regression lines quickly.